In traditional databases, in traditional systems, it's through the access that you have to the database that those changes are secured. So you may have access, or I may have access to a group of data.
Yeah.
So it's very rare that you can get to that granular level. And there's a number of reasons. One is because it's incredibly difficult to administer with databases today. Two, because it also affects the performance of those databases. Yeah. And thirdly, most vendors, and we particularly, we work at a level where we encrypt at a hardware level. So it's the disk. You know, like when you have a laptop, your disk now is usually encrypted. But it doesn't mean to say that once you're in the application that everything's encrypted. It's not. The protections that are there are just saying you don't have, you're not allowed access.
Yeah.
But if you really wanted to attack it, if you had the means to attack it, you could. And so what we want to do with distributed ledger and the secure key-based technology that Gospel gives us is we want to be able to, from the very start, from the foundations, the data is secure.
Right.
So this is absolutely key, Stuart. I mean, I think fundamentally, if we look at this, all these systems today are very secure, but they're built in this kind of layer upon layer upon layer way because they're reliant on architectures in ways that we design systems that are now 20, 30 years old in a lot of ways. Yeah. The advantage we have is that we've built this architecture from the perspective of understanding what the challenges that have arisen in that
It's about
time
the data,
are.
Isn't it?
So exactly, it's all about the data, and it's all about understanding that fundamentally that we need to bring security down to that fundamental basis data layer. We need to secure it by design, and it just makes a lot of things a lot more straightforward to do well and to do in a secure way without all these extra layers of filters and compliance and bolt-ons and so on.
But the reality is that we have to put all of these security measures, these architectures, post facto. So the code is written by the developer. It's not written to be secure. What we do is we put it in servers, we put it in applications, we put it in databases where we put security around it. With blockchain, the code, they can still write the code the same way, but they can only access this data if they are playing by the rules of the blockchain.
Absolutely right. I think that there's a phrase that's used a lot in technology, separation of concerns.
Exactly.
And it means only dealing with what you're doing here. If I'm writing an application to manage payslips, for instance, my concern should be managing payslips. Yeah. That's what I should be thinking about. I should be thinking about delivering the best experience for somebody who needs to interact with that. The security should be dealt with where it belongs, which is with the data.
And am I right here in saying then what you're doing is you're adding an extra layer of security?
No, it's from the foundation.
Right.
It's from the data, because everything... Do you remember the old phrase, data processing? You know, we talk about IT, we talk about IoT, all these... At the end of the day, all we are doing is processing data.
Yeah.
And you have to secure the data before you can start processing it.
Right.
We got this 30, 40 years ago when I started IT, but we kind of forgot this over the decades because we put more and more layers of architecture and technology on top of it. And then we suddenly had all the security people say, is this secure? So then we had to lock it all down at all these levels.
If I bring in another analogy here, the situation we're in today is that we've got a safe in the middle of Leicester Square and 400 security guards stood round it. What we're doing is we're taking that safe and we're putting it in an underground vault. And it's this fundamental change from the layers of security being around it to the security being inherent in what we're doing.